So moving ahead with the questions of definite integration, so that's the question for today, and it's a good question, bachcho. Okay, so how to approach it? It involves many concepts here. Of course, so we'll be starting with by assuming this to be I, and then the first thing is the property of tan inverse trigonometric function, and that too of tan inverse. Okay, so see. We have already seen while solving questions of sequence and series that we try to break the general term of a series involving tan inverse as the difference of two terms. The same concept I applied here, bachcho. Okay, so what I did was I just divided both numerator and denominator within tan inverse by 4. So we got 3x by 4 divided by 1 plus x square by 4. That's what we got. Okay, now see, in denominator I may write x square by 4 as x into x by 4, and when we write its difference, so what do we get? X minus x by 4 is nothing but 3x by 4. So that's it. So what does that mean? So therefore I will be writing my integral as integration from 0 to 2 1 by x tan inverse of, so in numerator it is x minus x by 4, in denominator it is x into x by 4. So which identity is it? So tan inverse a minus b upon 1 plus ab is tan inverse a minus tan inverse b. So we can write it here as 0 to 2 1 by x into tan inverse of a minus tan inverse of b. So that's the first step. Okay, now I'll be, of course, what other choice we have? We'll be breaking it into two different integrals, bachcho. 1 by x tan inverse of x with respect to x minus integral 0 to 2 1 by x tan inverse of x by 4 dx. Okay, now I don't see much of a choice here. Okay, but then I moved ahead with this and tried to convert tan inverse x by 4 to like tan inverse s form. Okay, so I'll be continuing with that part. So 0 to 2 1 by x into tan inverse of x by 4 with respect to x. Now here if I say let x by 4 be t. So what does that mean? Dx is nothing but 4 times dt, isn't that? Okay, and x is nothing but again 4 times t. Moreover, when x is 0, so if I call it as I1, so therefore integral I1 is when x is 0, how much will be the value of t? It's 0. But when x is 2, t will be 2 by 4, which is half. So that changes the limit though. Okay, but still let's move ahead. So x is 1 by 4t into tan inverse of t into 4 times dt. Now see, this is what we got then. Okay, and then that encouraged me to move ahead. How? Now I will write my integral, which is 0 to 2 1 by x tan inverse of x as the first term with respect to x minus I1, which is 0 to half, and then 1 by t tan inverse of t dt. Now I can write it as, bachcho, we can write it as, so this is 0 to 2 1 by t tan inverse of t dt. I don't think anyone will object to it because we know by retaining the limit of the integral and with the same function, the change in variable won't make any difference in the answer of definite integral. We all know that. Okay, so using that statement, and then we know if we take this negative sign, if I want to manage it, so how can I write it? I can write it as plus and then interchange the limits. So half to 0 1 by t tan inverse of t dt. Isn't that? Now which property? A to b and b to c can be written as a to c. So I can write, so therefore we can write our integral as a to c half to 2, and it is 1 by t tan inverse of t dt, and that's it. Okay, that's it. Now again see, it's 1 by t here and these two are reciprocal of each other. So again I thought to try 1 by t as something maybe y. So differentiating minus 1 by t square dt is dy, and therefore t is nothing but 1 by y. Let's put the values everywhere. So what difference will it make? Of course, since I considered the reciprocal, the limits will get interchanged. So it's 2 to half, okay, I, and then dt is minus t square dy. So minus, and then 1 by t is nothing but t is 1 by y, isn't that? So it's y into tan inverse of 1 by y, and then dt is t square, which is 1 by y square, 1 by y square dy. So what do we get here? So again, since it's minus, we will again interchange it. So half to 2, y and 1 by got cancelled, y into tan inverse of 1 by y dy, and since y is positive, it goes from half to 2, so it's positive, so that means it's half to 2 y times cot inverse of y, right, cot inverse of y dy. Now see, now what we will do, we will just say that adding this and this, so add 1 and 2. So adding 1 and 2 bachcho, so adding 1 and 2, what do we get? We get here, so it's 2i is equal to half to 2, 1 by t is common, and then we have tan inverse of t plus cot inverse of t dt, isn't that? So we see, because again why? Because y cot inverse y or t cot inverse c is the same thing, bachcho, okay? So now we know tan inverse c plus cot inverse c is pi by 2. So I is pi by 4 half to 2, and then it is 1 by t dt, which integral is, so pi by 4, and then integral is ln t half to 2, ln 2 plus ln 2, 2 ln 2, so the answer according to me should be pi by 2 ln 2 bachcho. Okay, so that's the solution of this question. So I think that that was a good question. See, that the way we approached it was important here. Okay, so I consider it to be a good question of definite integration. There are many steps which are going to be important for such or similar type of questions, bachcho.